Hello everyone, welcome to hands-on tutorial series on machine learning with the help of Python and skitlearn. In the last video, we discussed linear regression with single feature. In this video, we are going to discuss linear regression with multiple features. So here we are going to take the same dataset, and after taking multiple features, we are going to make a regressor, then do predictions on that. Later, we are going to split our dataset into train test part, and we are going to perform training and make predictions and show you how each feature is sort of representing overall with our output, predicted output. So let's get it started. First, let's open a new notebook. There we go, like this. Now let's name it something like multiple feature linear regression. So what does this mean, multiple feature linear regression? So basically, we took a dataset in the last video in which we had actually a target. Other than that, we had age, sex, BMI, SP and S1 to S5 and S6, all of these input features. So in the last video, what we did was we took BMI as an input feature, and on the basis of that BMI we were actually able to see what is the relationship between that and the target, right? In this video, I am going to do a little bit different approach in which I am going to take two features. So first, let's actually get to the dataset, and then we can have more discussion accordingly. So the few things that we are going to need is, the first thing is matplotlib. So let's write import matplotlib dot pyplot as plt dot pyplot as plt. So as you know, matplotlib is needed whenever we are going to perform visualization, and here, as you know, we are going to need that as well. So other than that, we are going to import numpy as np. Why is that? Because we are going to use arrays, right? And for pandas data frame, we are going to import pandas. So therefore import pandas as pd, and later we are going to import datasets linear model, both of these things from sklearn. So from sklearn import datasets comma linear underscore model. Now what do we want other than this? So there is only one thing that is remaining, and that is mean squared error and R2 score. Both of these are available in sklearn metrics. So let's take it out from there. Okay, from sklearn, right, dot metrics import mean underscore squared underscore error. Actually, maybe that will be enough, right? Maybe we do not need R2 score for this video. Okay, so let's see. Now that we have sort of imported all of the things that we are going to need, now let's load the dataset again. These commands are the same as the last video. So let's just write data is equal to datasets dot load, and the diabetes dataset is the one we are going to need. So diabetes, shift enter. Okay, load diabetes. I did not put an s here, right? So shift enter. Now what do we want? We want to make it a data frame. So let's write df is equal to pd dot data frame, and here I am going to write data is equal to data dot data. Note that these are the commands that we are actually picking up from the last video, right? So if you have any problem understanding them, I explained them in detail in the last video. So what are the columns that we are going to take? The columns are data dot feature underscore names. So I can actually show that once again here, so that there is no confusion, right? So let's write data here. So as you can see, there in data there is one thing that is named data, one thing that is named target, and one thing that is named feature names right here. So I have written data is equal to data dot data, right, and columns is equal to data dot feature names. These are the columns. Okay, I hope that everything is clear now. So now after this, let's actually just check the data frame. There we go. So this is the data frame, right, but without the target at the end. So to add the target, we have to actually sort of use the data frame command again. So let's write data frame target is equal to pd dot data frame, and here I am going to write data is equal to data dot target. Okay, so now that we have this, let's write shift enter, and after that let's see df again, right, data frame. So target is now added right here. What is the next step? The next step is to actually select the features. So these are all the input features: age, sex, bmi, bp, s1 to s6 and all of that. So here what I'm going to do is I am going to actually take two different features. So one feature will be the same, which is bmi, and the second feature will be bp. So actually let's see if there is any other feature which is changing a lot, right? Actually bp looks fine, right? Anyways, so for that to take two features, what we have to do is we have to make a 2D array of that two features. So x is equal to, we are going to take two columns from this. So the first column will be bmi, right, and the second column will be bp. So x is always in 2D, right, two dimensional, and y is always in single dimension. Here I'll write y is equal to df and target. Okay, so now that we have written the value of x and y, what is the next step? The next step is actually to make the regressor. So let's make it. So regressor is equal to, I am going a little bit fast because we have actually covered most of these things in the previous video. In this video there is only one thing changing, that we are using multiple features. Okay, so regressor is equal to linear underscore model dot linear regression. Linear regression, yeah, like that. Okay, so after this the first step is always to make the regressor. The second step is to perform the fitting, right? The first step is to make the regressor, the second step is to perform the fitting. So we have to perform fitting on the basis of x and y. Note that I have not until now made the division of the dataset into test and train, right? So I'll do that later. Right now I am going to train it on the whole dataset, meaning that on the whole column of bmi and bp and target, right? And then I am going to check a random value, right? So let's write regressor dot fit, and here I'll write x comma y. So linear regression has been done here. Now what do we want to do? We want to do predictions. Okay, so what is the value of y predict? So y predict will be equal to regr, regressor dot predict, and here I'll write some value such as 0.044451. I am actually taking the value at x of 2, right? Let's see, where is it? Yeah, this one, x of 2. I have taken this value, and in the same way I have taken this value. So both of these values have been taken. So I have written the first one. Let's write comma, and now let's write the second value with a minus, of course. So there we go, these are the values, right? Let's now make the prediction on the basis of that. Now what can we do? What we can do here is we can actually see what is the value of y predict, and then because we have put the values of x of 2 here, right, we can actually check the value of y of 2 and see how much are they similar, right? So let's write y predict. What is its value? It's 184.9. and now let's write y of 2, which will be the previous value that is already stored, right? So let's see how much good of a prediction our model is doing, right? So the real value is 141 and our model is predicting 184. It's not that kind of bad, but actually when we are using linear regression, we do not we know that it will not be able to capture the non-linearities. Actually it will not be able to capture anything that is not linear, right? We will cover those things when we move into polynomial regression and things like that, right? So anyways, this is the simple linear regression with multiple features. Now what is the most important part? The most important part is normally we have to also perform some sort of train test split, and after that we do the prediction again. So for that, let's just write x train is equal to remaining, I'll enter all of these values other than the last 30. So I did not write x here, okay, my bad. Anyways, in the same way, x test is equal to, so here only the last 30 values will be, last 30% values will be included. So for that, let's write minus 30 and then ratio sign. Now that we have made x test and x train, right? So actually let me just show you once. So this is x train, it has maximum 412 values, and in the real data set there are a total 442 values. So we have 70% values here. In the same way, the remaining 20%, 30% values are in x test. So these are the remaining values. Okay, so moving on, what do we want to do next? We want to actually make the y train and y test in the same way. So let's write y train is equal to y and minus 30, minus 30, there we go. And in the same way, let's write y test is equal to y of minus 30 and then ratio sign, right? Okay, so now that we have put in y test and y train as well, now it's time to train the model, right? So we are going to train the model on the basis of train data set, of course. So therefore we are going to write regressor.fit, and here what we are going to do is we are going to write x train comma y train. I hope that all of these things are pretty much clear to you. If there is any doubt in any of these things, you can actually look at the previous video as well. That is much more detailed than this video, right? Okay, so now what we can do is we can actually make predictions on y predict. So let's develop y predict. So y predict is equal to regressor dot predict, and here I'll write x test, right? So I am going to make prediction on the basis of test dataset, right? I performed a fitting on the basis of trained dataset, and I am making the prediction on the basis of test dataset. So there we go. Now we have two values. Let me show you what I am talking about. So the first value is y predict, the one that we have predicted with the help of our regressor, right? And what is the other value? The other value is y test, which is the actual data set value that is available to us. So the next part, to actually see the efficiency, what we have to do is we have to compare y predict and y test. This is the simple procedure that is followed in every sort of machine learning algorithm, right, to check the efficiency. anyways. So for the first thing, we can also check out the coefficients of regressors, right? So they are available in regr regressor dot coef coefficient, and there we go. So these are the two coefficients of our regressor. Now the next thing is, we can actually showcase the things such as mean squared error or R2 score. So first I'll show you the mean squared error between y test and y predict. So let's print out mean underscore squared underscore error, and here let's write y test comma y predict. So this is the mean square error that we are getting, right? In the same way, we can also check out the R2 score. Okay, and when we are talking about R2 score, 1 is the perfect score and 0 is the worst score. So let's see how much have we scored in the case of R2. However, there is one thing that I think I have not imported R2 score, right? I think so. Yeah, I just did not do that. I thought maybe I'm not going to use it. Anyways, now that we have time, let's do that as well. So R2 score, let's come back here and let's print out actually what is the R2 score, right? So let's do that by writing R2 underscore score, and here score, and here we are going to use two things, y test and y predict. So there we go. Not bad, not bad. Our linear regressor with multiple features has worked up to 51%. This is not bad, considering that we are into the most basic part of type of algorithm, right? So the linear regression basically does not work that much practically when we are talking about it, right? Mostly we have advanced algorithms that do work. So I'll actually try to use the same dataset and the same features for my remaining algorithms as well. In fact, if there is a problem, and then I'll be switching the dataset. So that way you can actually manage to see how these things are changing with passage of time. Now let me also show you a plot, right? So which will be for the x test and y predict, and the other one will be x test and y test, right? So for that, the first column that I am taking is BMI. So there are two things. One, I will be using scatter plot. So let's write plt.scatter, and here let's use x test BMI, and other than that let's use y test here. Okay, so the dots that are scattered will be with respect to y test, not y prediction. Okay, so let's write black here. After that, let's use plt dot plot, and here let's write x test BMI and y predict, and color should be blue, right? Something like that. Color should be blue, and at the end line width should be something like 3. So other than that, we have to write plt dot xticks, so that okay, we get x ticks and y ticks. So y ticks, we are not actually telling it what to do here, right? We just want a simplest sort of plot. So at the end, plt.show, let's run this. Okay, so there we go. This is the plot. As you can see, this is not a very good plot. It is not a very good plot, right? So it is showing that our model is sort of confused what to do, right? So it is not giving us a linear relationship here. Now there is some problem with this. Of course, that problem is because we are trying to do multiple features. However, as you can see, the accuracy or the result is up to 51%. So 51% is not that bad when we are talking about simple linear regression. When we move on to logistic regression, rigid regression, or things like polynomial regression, then these things will work better. So let's recap. In this video, I have told you how can you use multiple features for regression, right? And what are multiple features, how we can use them, 2 features, 3 features, we can actually use as much features as we want, right? So that way we don't have to worry that on which things our output is actually dependent upon. So our output is dependent upon everything, and then in that case we can use everything. So that's what we did. We developed a regressor, right? And we made prediction on 2 columns, and at the end we showcased the accuracy, which was not that good, but it will get better with the passage of time as the videos continue. So in the next video we are going to move on towards another regression technique, right? For now this is it, but keep watching our channel so that you can equip yourself with the best of machine learning and AI based knowledge. Thank you very much.